Hi everyone, welcome to lesson 2.1. This video is going to be dedicated solely to compound inequalities. So before we actually dive into that, I do want to do a brief review with you. So if you recall, we do have some symbols that mean less than. Okay, if you note, the symbol for less than actually looks like a capital L, only it's been slanted inward. We also have greater than. And we also have less than or equal to, so the less than or equal to actually has like the bottom half of an equal sign underneath it. So this is less than or equal to. And not surprisingly, we also have greater than or equal to. So to kind of bring this out a little bit more, the two symbols that you see on the left, these are known as strict inequalities. So in other words, they are a little bit more demanding, okay? So for example, we have maybe x is greater than 7. Okay, I'm demanding that the variable x has to be a value that is bigger than 7. So we can check this. So say I say x is going to be 10. If I put it into that statement, it should still ring true. So x greater than 7, in this case we're saying x is equal to 10. Is 10 greater than 7? I'm assuming you're silently nodding your head yes, and you would be correct. So that is a true statement, so we're okay. So now, if you start moving a little bit further away towards smaller numbers on the number line, then you might get in trouble. So say I say, all right, maybe x is equal to 7. So we're going to say 7, in this case, is greater than 7. Now, say that again to yourself. 7 is greater than 7. Not quite. So in this situation, we would have to jump in and say, no, that's not a true statement. 7 is not greater than itself, but it is equal. But in this case, we have a strict inequality. We're saying that the x value must be greater than 7. And of course, if we went the opposite direction and said, well, if I pick negative 32, negative 32 being greater than 7 is, well, just plain wrong. With the other sets of inequalities, when you bring in the equals, suddenly this would change. So if we start off with, say, something like x is less than or equal to 3, well, if I say x is negative 56, negative 56 I would definitely say is less than or equal to 3. So we would call that good. If we move further up on the number line and we say, well, what if I pick 3? Here we have a little bit more of a choice. Is 3 less than 3, or is 3 equal to 3? Since it does fit one of those conditions, we are okay to say, yep, that's appropriate. And then of course, if we go to the opposite extreme and say I pick 9, well, 9 is not less than 3, nor is 9 equal to 3. So here we would jump in and go, I can't use that. Okay. So that was just a brief tutorial on inequalities. Let's kind of move along here. So when you look at a compound inequality, we're basically saying that your variable is in between two values. So say, for example, x is in between 1 and 6. So this is actually an appropriate way of saying this. So when you have a compound inequality, you want the value on the left, in this case the 1, to be smaller than the value that you see on the right. Okay. We do want to make sure that we have some sort of order here. Also, in this case, we want it to be ordered so that you usually with compound inequalities have less than symbols in here. Okay. So it wouldn't necessarily make sense, because actually we could look at this on a number line. So we would say that if we had 1 over here and we moved it to 6 over here, well, we would say that all the values that would make sense are in between them. So again, we can kind of double check this and plug some values in. So let's say that we pick a value over all the way out here, say 0. Let's pick a value out here, say 8. And we can really pick any values in here that are in between. So let's say I pick 3 and 4, and let's double check these. Okay. So if I put 0 in for this one, let's double check and see if this statement is true. 1 is not less than 0, so already there is an error when you read through this. So here we would have to say, no, that is not true. So let's try again. 1 is less than, let's pick the 3, is less than 6. Is 1 less than 3? And we would say yes. And then we would also say, is 3 less than 6? We would also agree. So in this situation, this is a true statement. Notice that the numbers fall in a specific order. Okay. So if we continue, if we have 1 is less than 4 is less than 6. 1 is less than 4. 4 is less than 6. So we are okay. Now if we start picking values that go beyond 6, notice that things will begin to fail again. Oops. So if we have 1 is less than, in my particular example I picked 8, is less than 6. So let's go through. 1 is less than 6, that is true, but then when you look at the second half, 8 is less than 6. But 8 is not less than 6, so we would say, no, the center value would not work. Okay. So the idea of compound inequalities, it basically kind of bookends where your values that will give you a true statement are going to be contained. One other thing that I would mention is that the symbols that you see here, both of these in my example are both strict inequalities. You could use, for example, an example like 2 is less than or equal to x is less than or equal to 10. And again, I'm just picking random numbers in this case, but notice that the 2 on the left is smaller than the value on the right. Okay. You can also have these interchanged. So we could have an example such as -5 is less than x is less than or equal to 3. Okay. You are able to interchange those, and then again, we can also say something along the lines of 50 is less than or equal to x is less than 132. Okay. All of those statements will go ahead and work. Some things to avoid, it's just sloppy and you won't actually see, so what I'm going to note for you here is that these are all kind of wrong or inappropriate kind of interpretations. We would never really see something like x is greater than 5, but then you have a less than symbol over here that says 1. Your symbols, your inequality symbols, are going to be very similar, okay? So, and again, usually the way that we have them, or at least for now in this course, the appropriate way or the proper notation would be to use two less than signs, less than or equal to. So this would be very wrong or very inappropriate to use. Another one that you might have would be x is greater than. So you could use two greater than symbols, but it's just not quite appropriate for what we're doing. And in this case, if we use greater than symbols, the ordering of your numbers does need to be flipped around. So maybe we would put 0 over here and 20 over here. So the way that we would read this is 20 is greater than your mystery number x is greater than your mystery number 0. That is true. I mean, we still have it going in the appropriate order, but actually, to write this the correct way, we would want to flip the symbols around and actually flip the numbers around too. 0 is less than some value of x is less than some value, or is less than 20. So what we are saying here is that the x values that we can use are going to be between 0 and 20. Okay. I hope that you found this helpful. Please continue on with the lesson.